Hello students, welcome back. In this video, we're going to put some finishing touches on Signal Storm, and these are going to come in the form of visual feedback systems. So right now, anytime our player maybe clicks on a relay or sends a message or maybe gets hit with some noise, we don't really have a system to let the player know what's happening, right? Did something good happen? Did something bad happen? So in this video, we're going to focus on creating a bunch of various overlays that we can draw right over our game window, like flashes. Either flashes of a positive color to indicate that something good happened, or flashes of a negative color to say, hey, something bad just happened. We'll also look at maybe trying to display text in the center of the screen for certain events, such as sending a message. So we'll have an alert pop up in our window where it says message sent and then fades out over time. And then we'll look at trying to add a screen shake where anytime we hit noise, our screen, our game world will move back and forth to sort of indicate that, we just took some damage. And we'll look at a few other little visual tweaks that we can do along the way. And this is just going to make our game overall more engaging and fun to play. So let's head over to our computer screen and we'll dive right into our lesson. So I have lesson 8's starter file for our Signal Storm game here, game polish, open in vscode.dev. I'm going to minimize this and open that file directly in the browser. All right, so let's see what we've got. What are we working with? So right now we've got a few things going on. So the first thing we'll note is there is an overlay already active when I hit noise. And so if you look here, as soon as I hit noise, I get a solid red overlay that just stays the same sort of transparency the whole time. One of the things that we want to do is we want to fade that transparency over time. Similarly, if I collect enough bandwidth to send a message, let's see if I can get there. Let's see if I can get there. One more. All right, so I get an overlay there with that text that appeared sort of in the center of the screen, but they don't fade out either. They're just persistent. So we got to work on that system. And then another thing that we can add here is when I perform a ping sweep, I can register relays that have been hit by the ping. So let's see here. So when I register my ping, those relays light up. But that light up effect is not necessarily what I want in its entirety. So we've got a little bit to work that we got to do here in these visual systems. So let's head over to mission number 1. Mission number 1 says let's define our polish constants for the flash, shake, and feedback systems. So our system constants are going to come here in our student edit zone. So we can see we have our player, we have our relays, we have our bandwidth and integrity, our relay loss and gains, our ramp, our noise, our ping, and now we find ourselves with our visual systems, our polish constants. So when we hit noise, we have a flash duration. And so our flash, right now it's set to 1. I don't think we're following the flash at all because if you look, we just stay like a solid red color. There's no flash there at all. So we got to actually use this value, and we're going to flash for a very short amount of time. We're going to flash for 0.18 seconds is what I have it for. All right, and then we're also going to shake our screen. Right now, it's not shaking at all. We don't have that system in place when we hit the noise. But when we do, we'll shake for a very short time. I'll shake for 0.15 seconds. And then we need to shake our screen with a given strength. So the higher this number, the more visible the shake will be. I'm going to set it to 6. Similarly, we want to flash some text to the screen. So I have the flash duration for our text. When we send a text, when we send a message, let's just see. We're going to show a little bit of an overlay, and we will show. See, we show our overlay and we show our text. So we got to have a duration for both of those. And so the flash for that overlay, I'll set to be 0.03 seconds. And the text, I'll keep that up for a little while so that people can actually read it. I'll do 3 times as long as the flash, so 0.9 seconds. And then when we ping, we're hitting our relay. We saw our relays lighting up. We got to time that duration as well. So I'm going to do 0.22 seconds here. All right, and so that's just random numbers that I sort of picked. It seems to work for me, but you can always come back and change these. So now that our system constants are set, let's just see what else we're working with here. In our color palette, no new colors, no new variables here. What about in our gameplay variables? All right, in our gameplay variables, it looks like we got a lot of new things. We got a bunch of timers. Our noise hit flash timer in seconds. So that's going to control the flash when we strike our noise, making that red overlay. Our screen shake timer in seconds, our screen shake strength, message sent flash timer in seconds, and message sent timer seconds. Wow, we got a lot of timers. So how are we going to set all these and handle them? Well, the first thing we'll do is we'll go to mission number 2, because mission number 2 says all of those timers, when we reset our game to our default values, we want to make sure that we also reset the timers. We don't want any of those effects carrying into our next game. If we died from hitting noise and we have a red overlay and the screen is shaking, we don't want to keep that effect going. So reset game to defaults is where we reset every system, the player, the relays, bandwidth and integrity, message send, our runtime, our ramp, our noise, our ping, and now we'll reset our visual systems. So let's target a bunch of those timers. So I have noise, hit flash, and then I'll hit tab for autocomplete. Noise hit flash timer seconds, we'll set it to 0. Let's do screen shake timer seconds. We'll set it to 0. We might as well set screen shake strength to 0 too, because that could have changed and we want to make sure that it is back to its starting value of 0. And then we'll put message sent flash seconds, message flash timer seconds. We'll set that to 0. And we'll also set message sent text timer seconds. So that's the thing that's going to control how long the text is on the screen. So this is our flash. This is the text that appears. All right, mission number 2 is all done. So let's go look at mission number 3. Mission number 3 says we got to focus on the draw noise hit flash. So when we hit the noise, right now we're just getting this solid red overlay. We don't really want that. We want to fade out in time. So let's just go to our actual draw scene function. Let's see what's happening in draw scene. All right, so in draw scene, it looks like we got some stuff for with our screen shake, so we're gonna have to worry about that later. But we're drawing our background, our noise, our ping, our relay, our player, our HUD, and then we've got all these new overlays. So if our noise hit flash timer seconds is greater than 0, we're going to draw the noise hit flash. If our message sent flash timer seconds is greater than 0, we're going to draw our message sent flash. If the text timer is greater than 0, we're going to draw our message sent text. So this is like a brand new overlay system. So in mission 3, we're calling, let's see, if our flash timer is greater than 0, we're going to draw noise hit flash. So in here, we're saying no stroke. Give me an invisible marker so you do not see the outline of the shape that I am about to draw. And then it looks like we have a variable called %. And % is currently set to 1. All right. And then we create a color that looks like an RGB color, lots of red, a little bit of green, and more so of blue. So this is going to be like a pink color. And then it looks like we have an alpha channel. Now this alpha channel, the way we define our color, is going to be between 0 and 255. Right now, we're taking 60 and multiplying it by 1. So the alpha is 60. All right, well, I guess that's okay. I guess that's sort of right. But what we want to do is we want to fade this out. So for example, if I make it 0.25, now 60 times 0.25 is going to be 15. So now if I refresh the game, our overlay is going to be a lot fainter. Let's take a look. See, it's a lot fainter there. That's pretty good. So what we want to do is we somehow want to change this dynamically. And so the way we're going to do this is we're going to look at a fraction. So like if I did like, 10 over 20, well, that's a half. And then 5 over 20 would be 0.25. And then 2 over 20 would be 0.1. And we want to multiply our alpha by a smaller and smaller decimal. And the way we're going to get that is this bottom number is our maximum value. And in this case, this is going to be noise hit flash right here, our fourth one down. Noise hit flash duration seconds. We said this should last 0.18 seconds. And our numerator, the top part of our fraction that's going to be decreasing, is noise hit flash timer seconds. That's the value in our timer. So it's going to count down. 0.18 is what it'll start at, and then it'll go 0.17, 0.16, 0.15, 0.14, all the way down to 0, and we'll multiply each time by a smaller and smaller %, making the alpha lower and lower and lower, meaning we're going to be able to see through the rectangle that we are drawing with our transparent color. Let's look at this mission now. So let's see what happens if I hit my noise. Ooh, that was a nice flash. That gives me the flash effect that I want. Perfect. So that's working really, really nice. Now, I think we're going to try to mimic this structure in some of our other missions. So let's now look at mission number 4. Because mission number 4, we're doing another flash timer. But mission number 4 is for when we send a message. So similarly, we know we're calling draw message sent flash if the timer is triggered, if the timer is greater than 0. So we grab an invisible marker so we don't see the outline of the shape that we're about to draw. And now we got to figure out how are we going to define %? Because again, we're taking a RGB value with an alpha channel and we're going to lower the alpha to make it so that we fade that color out in time. Well, just like before, it's going to be a fraction. Like 10 over 20 is 0.5. So we'd multiply 70 by 0.5 and get 30. If it were 20 over 20, it'd be 1. If it were 15 over 20, it would be 0.75. So this bottom number is going to be our maximum value. And this time, since we're dealing with our message flash, we'll use message sent flash duration seconds, which should be about 0.3. Now, the numerator is the value that will change and decrease. And so this is going to be our timer, message sent. Oh, not text timer. I got that wrong. Message sent flash timer seconds. Tab for autocomplete is your friend. So we'll set this timer. We'll set it to 0.3, and then we'll decrease it 0.25, 0.2, 0.15, 0.1, 0.05, and then 0, and then we'll stop the flash. Now we'll see that alpha getting lower and lower and lower and lower, so we'll be able to see more and more of our background. Let's test it out. Let's send a message. All right, I gotta click that so it doesn't go off. Perfect, perfect. All right. Yeah, and that looked really good. That was like a nice, hey, you did a good job. Nice job sending that message. I like that a lot better. These flash systems are working much better now that they're not just like a constant. All right, so I think we've got another thing that we want to fade out over in time, and that is our, what do we want to fade? We want to fade that message sent, because right now that's pretty solid. So let's go look at mission number 5. Mission number 5 targets that draw message sent text. So we're going to mimic this one last time here because we want to show this and then fade it out over time. So we're creating this variable %, and right now we got an RGB value here that's going to be pretty much white. And here is our alpha. We're going to start with a full value, so you can't see behind it at all, and then we'll reduce it. So again, we're going to multiply by a fraction, 20 over 20. Well, this is 1, so 255 times 1 gives me an alpha of 255. Multiplying by 15 over 20 would be 0.75, 0.5, 0.25, all those good things. This bottom number is the maximum value. Since we're talking about drawing our message, this is going to be the message sent text duration seconds, which is 0.9 seconds. And our numerator is going to be the thing that changes. And so we'll target our timer for this system, message sent text timer seconds. So we'll set this to 0.9 seconds, and then it'll decrease 0.8, 0.7, 0.6, 0.5, 0.4, 0.3, 0.2, 0.1, 0. And as that changes, % will get smaller and smaller and smaller, which means our alpha will get smaller and smaller and smaller, and we'll begin to fade out the text. Let's test this out. This should be a really nice system that we have now with all of our different overlays. Let's take a look. Ooh, got to avoid that noise. Come on, I got to get out. I got to get out. I can't make it. One more. Oh, sugar. There we go. And there you see it fade nicely. So I think that the timing there works pretty good for me. I liked that. The flash is quicker than the text. I want the text to stay on a little bit longer so I have time to read it. All right, so I'm really happy with that. This flash system is working really great. Let's go look at mission 6. Mission 6 says, well, let's add one more flash feedback. And this is going to be for when the ping hits. So the system's already sort of in place. When I hit a ping, you can see that they flashed, but they just sort of filled up. And I don't necessarily like that. So let's look at mission 6. It says draw relays. All right, so we are grabbing our invisible marker. We're looping through all of our relays. We're figuring out what color it is. And then it says if relay dot ping flash timer seconds is greater than 0. So it looks like each of our relays now have a new property called ping flash timer seconds. Let's go look at the relay data object. So in the search bar, I am just going to type generate relay data. Let's go look what our new object looks like. Okay, so right here we have our properties, row, column, X, Y, type, timer seconds, max timer seconds, has been pinged, and then ping flash timer seconds. So this one is new. So each relay is going to get their own ping flash timer. And so when it encounters a ping, I bet we're going to set this timer. Let's go check the function that looks at a collision between pings and our relays. Where is it? I got to find it. I'm searching. Check player noise collision. That's not it. Check ping relay collision right here. Okay, so let's see. Here is where our collision has occurred. We've looked at that before. We set the relay, we add to the relay's timer. We either set it to 2 seconds, right? 2 seconds, or what its current timer is. We set has been pinged to true, and then right here we set that particular relay's flash timer to 0.22 seconds. So if we go back down to mission 6, where our draw function is, if that particular relay's flash timer is greater than 0, we want to draw that flash. And if you look right now, you're going to use that same method. So I'm really trying to hammer home this idea of how do you flash an overlay to the screen? Well, right now percent is equal to 1. Let's see, can you actually figure out how to write this so that the ping flash will fade out in time? Pause the video. See if you can give that a shot. Something's going to go here, and I'll give you a hint. It's going to be a fraction with something in the numerator and something in the denominator. Let's see if you can do that. Okay, maybe you paused the video and figured it out. Maybe you just waited and you said, this guy's just going to tell me how to do it anyway. You're absolutely right. I will. So in the denominator, remember, we want a fraction that is going to be changing. So like 20 out of 20, this would be 1, and our alpha here would be 180. And then if I decrease it to like 15, now this is 0.75, and then 0.5, and then 0.25, and this alpha channel, because percent is getting smaller and smaller and smaller, will get smaller and smaller and smaller, and it will fade it out. So we need to put the maximum value in the denominator. So in the denominator, this is going to be a constant of our system called ping relay flash duration seconds, 0.22. And then in the numerator, we are going to use this particular relays, so relay dot, and we're going to target their ping flash timer second attribute. Every relay needs its own flash timer because we're going to set them at different times, because if we look, the ping encounters them at different times. So I think that picked it up really nice. All right, so let's double check it. If I run it now, we get a nice little flash, perfect, and it fades out nicely in time. So let's get a few relays on the board. Let's see if I can get a couple here. All right, ready? And you can see that nicely. Perfect. All right, I'm really happy. So now let's look at mission number 7. Mission number 7 has us target our screen shake ability. So anytime we collide with noise, we're going to try to shake our screen back and forth. So this is a really kind of neat effect. And so we saw that we're already targeting this in our draw scene function. So I create two variables, shake X and shake Y. Shake X is going to be how much we shake in the horizontal direction, shake Y, how much we shake in the vertical direction. And if our shake timer is greater than 0, we want to shake our screen. So the first thing we got to do is we got to figure out, like, how much are we going to actually shake the screen? Because the shake should start off strong and then get weaker and weaker and weaker. So we want to start strong and then get weaker and weaker. And so we're going to reference that in this shake percent. So we've kind of seen this again and again. We're going to set up a fraction. And in the denominator, we should have the largest amount possible, right? Imagine it's 20. And in the numerator, we'll start it really strong. So 20 divided by 20, that's 1. That's like 100%. But then what we'll do is we'll count down this numerator, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10. By the time it gets to 10, shake percent is now only 50% or 0.5. And then it'll get smaller and smaller and smaller. So when we're talking about our shake percent, I have a maximum value that I'll reference as one of my constants. Noise, hit, screen, let's see, shake duration. Is it this one? Perfect. It was the first one there. Noise, hit screen, shake duration, seconds. So that's the maximum value. Well, then in my numerator, what we're going to do is we're going to put the value, the variable that is going to be counting down, and that is one of our timers. And so we had a timer here, screen, shake, timer, seconds. So when we set our timer, we'll set it to 0.15 seconds, and then we'll count it down. 0.14, 13, 12, 1, 0, all the way down to 0. Excellent. And then we got to get the value of our current shake. If you recall, we have a variable called screen shake strength. Perfect, right there. And we are going to take that and we are going to multiply it by our shake percent. So excellent, excellent, excellent. So let's go look for this variable. So I'm going to just highlight, I'll double click on screen shake strength, screen shake strength, and then I'll hit Control F and it'll put it right up here in the search bar for me. And we are at position 5 of 5. So let's go up 1, 2. All right. When we check for player noise collision, all right, so we've looked at this function before. This is where we actually collide with the noise. So then we set all of our relay timers to 0. They all go off. And then we set some cooldowns. But now if you look, we set our hit flash timer, our screen shake timer to the correct values, and we set our screen shake strength to its starting value of 6. So that's where we're setting these values that we've been working on. So now let's go finish mission 7 now that we see where we're setting these. Because if we look here, now that we've set the current shake, we're setting our shake x variable, which was 0, to be a random value between negative current shake and positive current shake. So it's going to start at 6, right? So if shake percent is 1 and shake strength is 6, 1 times 6 is 6. So this is going to say, hey, shake x somewhere between -6, which is going to be 6 to the left, or 6 to the right. It could shake it anywhere in between. It's going to be randomized. But the idea, and maybe I'll sort of like show it here, the idea is that that randomization is going to start strong. It's going to start between -6 and +6, and then that window is going to get smaller. It might go from like -4 to +4, and -2 to +2, and -1 to +1, and then just 0. So what you're going to see is a shake that could potentially be like this, getting smaller and smaller and smaller. And we'll do that both in the horizontal direction and in the vertical direction with our shake variables. All right, and then we're calling something new here. So I'll explain this. Even though it's already written for us, let's explain it. So we're saying push and pop. Those things work in tandem together because the magic happens when you call this translate function. Translate takes in two values, how much to move in the x direction and how much to move in the y direction. And so when you call push and pop, you are essentially saying, I'm about to provide some operations on things that I'm going to draw, and I only want you to apply it to the things that are in between push and pop. So we translate and we shake the background, our noise, our ping, our relay, and our players. But we don't shake our HUD or any of our overlays because they're not inside this push and pop. So that's a nice little way you can add effects to just certain things that you are drawing. So let's go check out in our shake method. Let's see. So I'll refresh the game. We'll come over here. All right. Ooh, and there was our little shake. That's just perfect for me. And it matches up nicely with that overlay, our flash. Really, really good. Now there's one last thing that I'm going to do, and I think we can make our noise look just slightly cooler. I kind of want to make the noise like pulse and glow. And so we're going to work on that in our last final mission, and that's going to be mission number 8, our noise flicker. So right now, if we look, we're putting paint in a paint bucket here for our noise. That's a specific color with some alpha, and we're multiplying it again by a value. So we've seen this a while now. If this flicker value changes, the alpha is going to change, and we can fade the noise out. But we could also fade it in if the value is increasing. So what we want is we want to get some way to increase, then decrease, and increase, then decrease, and increase, then decrease the flicker value. And that is going to happen through some function called the sine function. So if you're unfamiliar with what a sine wave looks like, I'll show it to you right now. A sine wave is something that looks like this. Okay, I'll say +1, -1. It looks like this. It starts at 0 and it goes up and then it goes down. And then it gets bigger going in the opposite direction. It gets bigger going down and then it goes to 0. And that's just one cycle of the sine wave. Okay, that's just one cycle. But the sine wave continues. It repeats itself over and over and over again. So then it goes up and down and up and down. And it just keeps going on and on and on. And so what we're going to do is we're going to use this sine wave to control our flicker. Our flicker is going to get bigger, and then it's going to get smaller. And then it's going to get bigger in the opposite direction. And then it's going to get smaller. And then it's going to get bigger in the opposite direction. And then it'll get smaller. And we'll do this over and over and over again. We'll repeat the cycle as long as our game is running. We'll use our runtime seconds to control the sine wave. So let's change flicker from 1 to something that will grow and shrink. We'll plug in sine. Now, if I just put in a actual number, like, I don't know, sine of 50, let's just see what happens. Does it change at all? Let's just look. Nothing. It's like always barely there. Nothing is happening because 50 is a constant number. We need something that is going to change, something that will cause us to move a little bit further down our x-axis as time goes on. And so we're going to use run time seconds. That's our variable that's keeping track of how long we've been playing. So let's take a look now. All right, we need some noise. Still, ooh, there it is. It's starting to flicker. I saw it. It's just that the flicker was way. There it is. It's like a really slow flicker. You can see it fading in and fading out. So how do we speed up the flicker? Well, all we do is inside of here, we can multiply by some number. The bigger the number we multiply by, the faster the flicker. And so I'm going to set it to, let's just be funny. Let's set it to 100. I don't even know what's going to happen here. I don't think it's going to be good. I'm not going to like it. Let's just set it to 100. Whoa, that flicker is way too fast. It's like glitchy. I'm going to set it to, I'm 18. I'm going to pick 18. Let's set it to 18. Let's see how this looks. Oh, that looks way better. I really like how that now looks. It's like our noise injections are coming to life. Perfect. And so the last thing that I'll do before we give a final playtest here is say, you know, this ramp was super helpful for us when we were debugging our game, but now our game's done. Our game is complete, so we don't necessarily need this ramp anymore. So let's get rid of the ramp. So up in your search bar, let's go to Draw HUD, because that's where this appeared. And I'm going to just scroll down to where we were calling the draw ramp readout function. And right now we will comment it out. So 2 little bars here. So this is like our debugger. When we need help, we bring it in. And when we don't need help figuring something out, we can take it out. And with that, Signal Storm is complete. This is awesome. Let's give the game a full, proper play test. So I'm going to refresh the game, and here we have it. Okay, our start menu here, Signal Storm. Stabilize relay nodes and transmit outbound messages. Avoid signal noise and maintain network bandwidth and integrity. So, all right, so I'm going to start collecting. All right. Avoid the noise. It'd be interesting to see how many of you kept the noise as automatically setting off all the relays or made it game over. Let's see. So I got to move around. Perfect. Picking them all up. I'm going to send out a ping sweep. All right. My relays light up nicely. My overlays are working great. Okay. Oh, I hit the noise, and that flash was just the visual feed. Oh, I hit the noise. That flash was just the visual feedback that I needed to know that that's not something I'm supposed to do, that those are an ouch. I'm going to use a ping to get rid of that noise because I was trapped. I'm sort of trapped there. All right. Can I get that one? Oh, I can't. Shoot. Okay, I got to ping those, reset them. Now I can pick them up, get behind it over here. Perfect. So this game definitely picks up. I'm trying to think, what was the ramp value we had? I think our total ramp time might have been 2 minutes, 120 seconds. So, oh, I missed that one. 120 seconds. So we're like halfway there on the difficulty curve, just over. I've got 5 messages sent, so I'm doing a nice job. Let's see. Can I get, oh boy, I just snuck through there. Ping. I got it. Oh. I'll tell you what, it's kind of fun avoiding the noise. Oop, missed it. I'll ping that. Oh no, oh no, oh no. Ah, I lost it right there. I had too many of those orange relays, which are like our double damage ones. They take away bandwidth and integrity go off. But I think I did pretty good. I sent 7 messages, 7 outbound messages. So this was a great example of a game that has lots of systems all working together. It's pretty intricate how we combined our player system, our integrity system and bandwidth, our relay nodes, and the scoring that we get from them for clicking them or missing them. We have these noise injections, we have the ping sweep, and then we have all of our visual systems and the difficulty ramp and timing that sort of puts it all together. So this game is quite fun. I really like playing it, and I think that if I really tried, I think I could beat 7 outbound messages. So that's my goal. I'm going to continue playing this game until I can at least get 8. And in the meantime, I hope you keep playing, and I hope you keep working on the code in this game to take it from this state, something we made together, and turn it into something that is truly your own. So I hope to see you in another video.